Okay, so obviously we're starting the steps of balancing equations. I'm going to give some examples and we'll practice as we move along, but one of the real keys to recognizing and knowing how to balance an equation is to know how many of something you have. I mean, if the first step is to count the number of each atom per side for the reactants or products, you need to know how to do that. So let's say we have a formula. Let's say it's aluminum sulfate. Okay, aluminum sulfate. So the reaction says, sodium sulfate and aluminum chloride react to produce blah, 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 and it says aluminum sulfate. You need to know how to write the correct formula. So we should know that this is an ionic compound, aluminum reacting, or aluminum getting together with sulfate. We remember that aluminum, we look to the periodic table, is a 3+. Sulfate is one of those polyatomic ions, SO4 with a 2- charge. We've got a 3+, a 2-. We need to find the least common multiple, which of course is 6. All right, and so we would need 2 aluminums, Al2, and we would need 3 sulfates in order to balance those charges and have the proper formula for that compound. So Al2SO4 3. Now, the reason I'm talking and what we want to do on this slide is go ahead and make sure that we're comfortable with how many of each there are. So if I say, how many aluminums are there? Okay, how many aluminums, how many sulfurs, and how many oxygens? We need to realize that the subscript tells you how many there are. So 2, there are 2 aluminums. Okay, the parentheses shows that this 3 gets distributed to both. Okay, so, and again, really, why is that? Well, because if I look at balancing these charges, I need 2 aluminums, each with a 3+ charge. So notice that's why there are 2 aluminums. And I need 3 sulfates. And each sulfate is a 2- charge. Notice that I have 3 sulfurs. Okay? And this 3 on the outside of my parentheses also shows that it gets distributed to that. So there are 3 sulfurs. How many oxygens? Well, that 3 distributes to that 4. We're multiplying. And notice you could count it right here as well. We have 4, 4, and 4. Or 4 plus 4 plus 4, of course, is 12. Or in other words, this 3 distributing to this 4, we have 12 oxygens. So it's important to know how many we have. So if we look at aluminum sulfate and we need to balance the equation, we need to know that there are 2 aluminums, 3 sulfurs, and 12 oxygens. Now the additional piece to that is what happens when we have a coefficient in front. So if part of what our reactions are in balancing equations is putting coefficients in front, then we also need to recognize that if I put a coefficient in front of that, so let's say Al2SO4 3, and I have a 3 in front of that, okay? We need to recognize that that 3 distributes to all of them. So 3 distributes to the 2, we would have 6 aluminums there. We would have the double distribution, I guess you want to think about it, because we have 3 sulfurs in the first case, right? We had 3 when it was just this, but we also have the 3 in front, so that's going to be 9 sulfurs. And if we had 12 oxygens initially, but we have the 3 in front, now we have 36 oxygens. So again, knowing that the parentheses, and if there's any subscript outside the parentheses, knowing that that distributes to both, and then when you throw a coefficient in front, it distributes to all of them. Okay, so really important to recognize. If I show you one more, and just really quickly, let's say we have, iron 3 acetate, and I don't even know if this is possible, but let's just say we have that. Okay, and I have 3 in front of that. Okay, let's not do 3 because I just did 3. How about we do 2 this time? Okay, so we should be able to figure out how many irons, how many carbons, how many hydrogens, and how many oxygens. Well, this 3 does not distribute to the iron because the 3 only goes to the parentheses, but I do have a 2 in front, so I have 2 irons. Now I need to do some distribution. 3 times 2 is 6, but again I have that 2 in front, so I have 12 carbons. I have 3 times 3 is 9, times that 2 I would have 18 hydrogens, and 3 times 2 is 6, times that 2 is 12 oxygens. So this, and again let me clean this up just so you can kind of see it, this formula and coefficient package, this formula and coefficient package would have this amount of each of those. All right.